Here we have a problem that we want to algebraically solve for x in degrees, all solutions to at least one decimal place. And this is our function, our equation is sin x plus tan x over 1 plus cos x, which is equal to this fraction. So let's start by simplifying our fraction of numbers. 23,209 minus 24,166 is negative 957. Dividing that by 10 gives us negative 95.7. And we can just copy this down. Actually, let's think about how we can simplify this side while we're at it. So we're wanting to try to simplify, and to do that, I want to try to get rid of this fraction here. So to get rid of a 1 plus cosine, let's first multiply top and bottom by the conjugate of the denominator. So that will make sin x plus tan x. And we're multiplying all of that by 1 minus cos x. And the denominator will be the two conjugates multiplied together. So 1 plus cos x times 1 minus cos x. So then, distributing top and bottom, sin x times 1 is sin x. Sin x times negative cos x is negative sin x cos x. Tan x times 1 is tan x. And tan x times negative cosine, let's think about this in terms of tan is the same thing as sin x over cos x. So because of that, when we multiply tan or sine over cos by negative cos, this cos and the cos on the bottom is going to cancel out. So that leaves us with minus sin x. And distributing the denominator, 1 plus 1 is 1. 1 times negative cos x is negative cos x. Cos x times 1 is plus cos x. And cos x times negative cos x is negative cos squared x. And that's all equal to this number. Okay. So from here, our sin x and our minus sin x on the top can cancel. So just for simplification, I'm going to write the tan first. So tan x minus sin x cos x over the cos x and the minus cos x will cancel out and leave us on the bottom with 1 minus cos x, cos squared x. From here, we can use the formula, the Pythagorean identity, that since sine squared x is equal to 1 minus cos squared x, we can simplify the denominator to sine squared. So that makes tan x minus sin x cos x over sine squared x, and still bring down our number. Now we want to see how we can simplify this. So remember again that we wrote before that tan x is sine over cos. So let's factor out a factor of sine out of the numerator. So sin x times, if we take the sine out of the numerator out of our tan, Then there's nothing on top, so we'll leave just a 1 on top. 1 over cosx minus, if we take out the sign, we're left with cosx for the second term, and then over sine squared x. So from here, this factor of sine will cancel out with the square factor of sine, leaving us with, I know this is a lot, leaving us with 1 over cosx minus cosx all over sine x is equal to our number. So now, let's find a common denominator to make the numerator a single fraction. So that'll make 1 minus cos x minus, we'll make this cos squared over cos squared x over cos x all over sine x. So then when we subtract, it makes 1 minus cos squared x over cos x, and that's all over sine x. And to write this as a complex fraction, I'm going to write that as over 1. All right. So now, again, we wrote before that sine squared of x is equal to 1 minus cos squared. So let's write this as sine squared x over cos x. And I'm going to flip the denominator and multiply to make 1 over sine x. So now this factor of sine can cancel out with that factor of sine, leaving us with sine x over cos x is equal to our number. And keep in mind that tan is sine over cos, so we simplified all of that craziness down to just tan x is equal to negative 95.7. So now, how do we find x? We take the inverse tan of both sides to make x is equal to tan inverse of 95.7. And then using our calculator, make sure your calculator is in degrees since the instructions wants our answer in degrees. And on my calculator, I get that to be x is equal to negative 89.401. It's said to round to 1 decimal place, so the 4 will stay the same and will be negative 89.4. And because we want all solutions, keep in mind that since it's simplified just down to the tangent function, that tangent repeats every 180 degrees or every pi radians. So we can have this to repeat by just doing plus 180 n, where n is an integer. And I'll just put our degree symbols since we're in degrees. All right, that was a big one. So I hope that all made sense. If you have any questions, feel free to leave those in the comments below. Also, down in the description, I have my email if you have any questions that you'd like to see a video of, and it's easier to send in an email, like as a picture format. Please like and subscribe, as well as share with anybody that you think might find this information useful. Happy studies!